All right. Welcome, everybody, to this Give Me Cloud Talks session from myself, Dwayne Nowick, and the organizers of Give Me Cloud Talks, and also sponsored by Captain Hyperscaler. This is a session. This is one of our sessions from our user group for to support the Global Azure event. And with me today is Neel Shah, and Neel is going to talk about unlocking the power of serverless computing with Azure Functions. So I will turn it over to you, Neel. Have a great session, and thanks everybody for tuning in to this Global Azure session. Looks like we lost Neel. We'll give him a second to get back online. There he is. Okay. All right. You're
Hello.
back, Neel.
Yeah. What about like what happened? I didn't do. Like, let's go ahead once. Just a minute. Give me 1 minute. I will just share
No
the
problem.
screen again.
All right. Here we go. All right. Back to you, Neel. Have a great session.
Okay. So let's start our today's amazing session on serverless computing. The title says Unlock the Power of Serverless Computing with Azure Functions. So yeah, this is Neel Shah, building various DevOps communities in my local region like Google Cloud, CNCF, Docker, HashiCorp, Grafana, and more, and have mentored more than 15 plus hackathons. So yeah, a little bit of community guy. Let's move ahead towards today's session. So first understand what is serverless computing. So in a layman language, when a cloud provider provides you an execution model where it manages all the infrastructure automatically, then it's called serverless computing. And it helps developer to focus on the main code, not writing or changing the infrastructure recurrently as per the demand. So yeah, that's it. So let's shift from traditional models. So what we are doing in traditional models as whenever our VM or our like storage goes out goes up to 80% or up to 90%, then we add another VM, another storage on that. So it takes a lot of time. But when we are using uh, serverless computing, it automatically scales up and it also automatically scales down whenever the traffic is low, whenever the storage is proper. So yeah, let's move to serverless computing. So what are the key advantages of serverless computing? It's cost effective. So let me take one example. So whenever you have infrastructure of X amount, then you are paying A amount. And when it goes up to 2x, then you are paying to 2x, 2A. And whenever the traffic is low down, it will be to 1x. So you don't need to configure it 1x, 2x, 1x, 2x sort of thing. So it is cost effective there. Next point is it's scalable. Eventually, everything is the whole architecture, the whole infrastructure is managed by the cloud provider. So you don't need to worry about that. And one of the example of scalability can be taken as on some of the big billion days or like Black Fridays, some of the e-commerce application have a lot of customers. So scalability can be understood there because on a normal average day, there would be only 100 customer on their e-commerce shopping, and on the Black Friday where there is almost 40 to 50% off, there will be more than 1 lakh customers. So it need to be scaled the server automatically. And then third thing is focus on the code, not on the infrastructure. Need to configure the main thing, and the infrastructure could be handled by the cloud provider. So yeah, how the evolution of serverless happened. So back to previous times, so there were a lot of big computers, big hardwares, a big computer having hardware like which takes a lot of room. Then it came a smaller computer. Then after the computer, it came virtualization where we were utilizing the different OS on a single hardware. Then comes there in our cloud computing, where every person are storing their data on cloud and utilizing and hosting their website, like everything on cloud majorly. Then came containerization. People make containers and ship it to anyone for easy communication. And yeah, then people are shifting towards serverless. And last almost 4 or 5 years, the serverless computing has become very trendy because people are using their time in a proper manner, not wasting that time on the infrastructure. So, what are the key concepts? So, how the serverless works? So, first thing is it's an event-driven execution. So, the major thing is serverless functions. When we will talk about Azure functions, so they are event-driven. Why we say event-driven? If something is happen, then only it will trigger. Otherwise, it won't. Next is automatic scaling, as we discussed previously. Next is payable execution. So yeah, it's very flexible towards cost. Why serverless? We already discussed all the points. Cost effective, scalable, focus on code, not infrastructure. And fourth is event-driven model. So let's jump to the main topic, which is Azure Functions, which is serverless compute service provided by Azure. So it's event-driven, automatic, scalable, for execution. It had all the features which discussed previously. So it supports many languages in the sense you can write the function code and different languages. You can also say it's a cloud and language agnostic because it provides you the code of functions can be written in Node.js, Python, Java, .NET, Go, and many more packages. So let's have simple demo of Azure functions over here. So go on to Azure, portal.azure.com and search for Azure functions, and you will see the screen which is shown on your screen. Create function app, select the subscription. So for all the Azure users, the subscription is the main thing. Behind with after subscription, you need to select the resource group where you will put the function over there. Write a function name. Then you need to select the languages and which text stack you want to do. So I had selected Python first. So you can see in Python, the operating system only available is Linux. So I will just change to Node, and there are two operating system, Linux and Windows. So yeah, for some operating system, both the like for some of the language text stack, both the operating system are available. And then you can go to consumptions, function premium, and app services plan. So these are the most common things. They are all providing serverless computing. But yeah, some of the premium features could be utilized in function premium and app services pack. Next, we can go to storage. We can add a storage account where the function will be deployed to there, and it comes to networking. So you cannot enable the public and private access over from here. Next comes monitoring. So if you want to enable monitor system behind this, you can also enable from here. And if you want to like deploy and also use this function in a CI/CD or GitHub CI/CD or Jenkins sort of thing, and Azure DevOps, you can use it. And yeah, of course, tagging is also important whenever we are doing uh, infrastructure on a large scale. So yeah, you can see on the top that the initializing of deployment is there, submitting the deployment is there. It will take some time, but yeah, I will just jump ahead a little bit. It will take some time. Yeah, see, your deployment is complete. You can go to the deployment. It was named as Neel test. You can see the matrix over there. See, yeah. So the function has different templates. Different templates are the HTTP trigger. When some HTTP request is occurred on the function, then only it will trigger. There are queue trigger are like the messages in queue. Message queue you can also use. There's a Cosmos DB trigger. When some document or something is changed in the storage, then it will trigger. There is a block trigger, and something is changed in the block storage. So yeah, there are different triggers you can use. We will use HTTP trigger over here. So creating a template for our function. The function is successfully created. You can get the direct URL from the get function URL, which is shown above. You can use somewhere if you want to use this function in a synchronous manner with multiple functions. You can go to code plus test where you can test the function once before launching it. You can see the template was pre-built and we hadn't changed anything. So yeah, you can change the code over here as per your requirement. I'll just change some sort of thing to show that the function is working or not. I have given key value pairs name equal to Neel. And yeah, see, you can see, hello Neel, this HTTP function executed successfully. And if I remove, what happens? Nothing was given as a an output. So at what there? The output there. Yeah, that was basic understanding of how the function works. You can call various different triggers, different functions. So yeah, let's go ahead. So what are the main use cases of the serverless functions? You can use in some of the webhooks and API integration with third-party apps to your application or to your product. Next is real-time data processing. So whenever we will discuss the proper use case of this, but yeah, there are some quiz apps sort of thing. So which are taking real-time data of everyone, of every people, and also when we are giving a proctor exam. So at that time, we are directly pushing the answers over there. So at that time, real-time data could be given to the backend directly using this. functions. Next is image and video processing. So when we try, so as we stored our data in cloud, we have less amount of storage. So we would try to do try to upload a lesser stored image or video over there. So what we can do is when someone uploads a video or audio, sorry, video and image to our application, then we can trigger one function which will resize the video to the particular limit and it will upload to our server. So in this way, we can have the optimized storage forever because as we are storing everything on cloud, it may cost a lot to us. Next is microservice architecture. So as we all have shifted from monolithic to microservices, so we can call different microservices application recurrently, synchronously through this, calling different functions. So let's see other examples. So building a web API, a normal example which we discussed previously. So there HTTP trigger can work directly. Next is when you process some file uploads, then blob storage can be triggered directly through functions. So some of the use cases which are used by many other people. Next is serverless workflow. You see the functions which I told. Use many functions recurrently. If A is called, then only trigger B. B is called, then only trigger C. So these ways the functions could be triggered and yeah, it can be optimized in some manner. Next is if something is changed in the database, let's say database change response, then you can trigger function for the cosmos DB. Next is for the message queue system, you have service bus, event hub, queue, storage in Azure. So yeah, you can trigger that directly. Next is the IoT data streams. So yeah, I had one good example. I will discuss after this. So yeah, many places in IoT serverless functions are used. So as we are in an arena of home automation with some of the cool IoT devices. So yeah, many people are also using this. And next is process real-time data using functions. You already discussed. So yeah, this is a normal example when we push our code to GitHub. It's a third-party app to our product, and the GitHub will trigger Azure functions, and Azure functions will trigger to another third-party app that is Slack or something that will post a message or something in our Slack. So this will like large sort of customization is applicable, but yeah, to understand to connect to third-party apps, you can also use Azure functions. That is also one use case. So next is serverless mobile backends. So for this particular use case, I can take one example is when there is a great football match or and our, like we are all are telecasting on the online mode. So when everyone is saying that the service provider, the application owner sends some notification to everyone, and as per the response of the every people, he will change his things. Let's say example, two matches are going on parallelly of football or something, and one match, people's responses are very good, and people want to get more. Then what the application provider can do directly, they can have the response from the users, and through that response, they can definitely trigger some new notifications. So yeah, that's a good pretty idea. Next is serverless IoT backends, which I definitely told you about the home automation. So uh, it's an arena where we are switching off our phone and lights from our phone. So how they are working? Some sensors are there, and we are passing this response over there. We can just see the example over here. There is a sensor of temperature. If that sensor has reached temperature up to some limit, it will send It will communicate to the IoT services and it will trigger the Azure function. And through that, the ceiling fan can be turned on or turned off. So in most of the IoT things, this could be there and it will be really beneficial. Next is, yeah, what I already told you, video and image analysis. So there are two things. First, which I already told you is when someone uploads video, then the size of the video should be resized to our limit and should be uploaded there. And the next thing is for image, also the same thing will be happen. And yeah, but the quality of the image shouldn't be lowered much. Next is what are the best practices for Azure functions? So design stateless functions. So uh, as per also microservices, but try to use the functions independently because what happens is when we call function A, Azure function A, Azure function A calls Azure function B, Azure function B calls Azure function C. So when A takes a lot of time, when A gets triggered, B will be triggered, but when B gets a lot of time, the C will be stuck as per that time. So to handle this sort of scenario, try to use them independently. Try to use some other services with that. So when a function A calls, go to something, some database or something, come back ahead with Azure B function, come back ahead. So yeah, this way it will be beneficial for designing like the things in a very proper way. Next is handling dependencies efficiently. So you need to have use some lightweight libraries, optimize your dependencies to reduce the cold start time. We will also discuss about cold start because it is very essential for the serverless functions. Next is setting up monitoring and logging. So eventually, on Azure function, as we already have seen in the demo, monitoring is also there directly. But yeah, why monitoring is important? Because we can directly see the amount of CPU utilization, the amount of read write operations, the logging where the server like uh, in terms of the recurrent functions, stateless functions, when the server when the function breaks, so logging would be helpful over there. So eventually, monitoring and logging is important to improve the performance and also to troubleshoot issues. So optimizing Azure Functions performance, how we can do that? Yeah, cold starts and warm up strategies. So what's this? I will just give one example. When you have one car and you don't drive that car for 1 year, the cost of maintenance would be a lot of money. Similarly, you have a car and you drove that car recurrently once or twice a month. Cost of maintenance would be lesser as compared to the thing which you didn't grow for 1 year. Similarly, this cold starts are the thing when you are don't use the function and eventually on the function the large traffic has came, so it will broke down. So for that you can do is so for that you can do is uh, you can trigger some functions recurrently on recurrent time. Let's say after half an hour, not say half an hour. Let's take 1 week. Every 1 weekly, you can trigger the functions. That's a good bad practice. Yeah. Next is minimizing function execution time. So how you can minimize and optimize. So for that, you need to have monitors and you need to execute functions in parts. So after for some part, the function has taken how much time. So eventually you need to perform some testing over this. And yeah, with that you can utilize. and minimize the function execution time. Similarly, find out the timeout values because we know as a person, if the function is taking 10 seconds, we will prefer 12 seconds to be finished the function. We will have 2 more seconds. So yeah, 2 more seconds are perfect. But yeah, in some case, we have the function is taking only 10 seconds. We have kept 20 seconds, 30 seconds. Then it's not appropriate. So try to utilize it will be you can do this only by testing. Yeah, this is also one of the things which is important, and you should also implement this. Next is ensuring security in Azure functions. So everywhere security is important. Yeah, so security have a major role in our every product in every project. So use IAM properly. That's a simple thing. Use Azure Vault to encrypt your some of your things, and have it in a granular role. Next is securing function code and dependencies. So avoid hard coding sensitive data in your code and utilize secure methods for storing and return credentials. Use some uh, key vault storage sort of thing where you can store your some sensitive data and call it there. You and sim like and explaining in a normal way. When you use GitHub, you have GitHub secrets stored there. Then you should store the secrets. You don't write the secrets in the GitHub code and the normal code. Yeah, similarly, you can use this. So it will help you to have say, like one layer of security. But yeah, also on the top of that, you can also use your DDoS for protection prevention. So there are many policies which will help you to have a greater security. Handling sensitive data, yeah, as I already told, you use Azure Key Vault for that, and that is really helpful. And that must a good practice for everyone. So yeah, it was an arena where everything was physical, server like server sort of thing, and it came to virtual containers, serverless, and you can have the whole differentiation where which thing was available. Microservice prevalence, deployment speed, high availability, scalability, operational cost, operational overheads. Here you can see the whole evaluation of service delivery and servers to serverless. So yeah, and I will just share some of the good resource. We had created a GitHub repo for this, where everything related to every cloud is there, so you can utilize it. If you have any questions, feel free to connect with me from this. You can scan the QR code or go on to the link. And yeah, feel free to reach out to me through any my socials. Thank you.
Great. Thank you very much, Neel. Great session. I appreciate your time and giving this great information to the global knowledge attendees. You know, global the not global knowledge, global Azure attendees. So I look forward uh, to this great event. You know, Global Azure, for those of you that aren't knowledgeable around Global Azure, it's a annual event that's put on by the community for the community. So it is a 3-day event that provides information, you know, like Neel is doing, volunteering their time and their energy to provide this information to everybody. So thank you again, Neel, and thanks to everybody attending this session and all of the Global Azure sessions. And we will have more sessions from Give Me Cloud Talks throughout the event of between the 18th and 19th of April. The event does go into the 20th of April, but we're only doing the 2 days. So thanks everybody, and have a great rest of your day.
Thank you everyone for joining, and a great applause